good morning. Okay, we have come to the end of the semester. One moment. Feedback. Hello. 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 This is okay. All right. Well, we wait for this thing to. I think it's position. Hello. Okay. So I guess I can't stand there. All right. So while we wait for this thing to start up, let me just quickly congratulate you for surviving this far. Okay. And also a PE. Okay. This is obviously, as you know, the last week of the semester. This is bad. Okay. And so, good news is that what I have covered to last week is pretty much sufficient for the final exam. Okay. So today, pretty much we are just doing some what I would consider like enrichment sort of material. But then hopefully you won't ignore it because essentially you will see it next semester, most of you. Oh, you right. So hopefully you will pay attention. I see. This is very slow today. Sometimes it's very slow. Okay. Give me a moment while I load up this thing. It's really bad. Put a clicker again. Terrible. Never mind, I only $68 today. Very slow today. All right. Very good morning. Sorry, it took a while today. Okay. So first of all, I realized something when I was coming down. I realized that so this was last Friday. So I realized that these are two people, kind of winners. Okay. So myself, congratulations. Hanlin was close. So unfortunately, I forgot to bring the badges today. But never mind. Later, when we have I show you the video, you guys can I'll go get the badges for you. So I'll give you later. Okay. Congratulations. Okay. So the other thing is this, many of you, I think about 10 of you, or I forget how many, but 10 of you have submitted this OOP contest submissions. Alright, so those of you who haven't given your game a name, I asked Tang Xiao to email you. Okay, so he's busy preparing the survey. Okay, so hopefully by today, so by today, hopefully the survey will be complete, and then he will basically, I'll send an email, and then I'll send you a little note, and you can vote. Okay, so the way it works is this. Okay, so Friday is the very last lecture. Okay, I think it's too much of a hurry to ask you to play the games for the next 2 days. Right? So the way it works is the following. We basically will give you the whole week next week. That's reading week, right? But not many of you want to study the whole week, right? Okay, so very likely what happens is you study a bit, you're bored, right? Then you play one game, and then you study some more, you're bored again, play one game, and then after that you have 10 games, so you have plenty of things to do for the next 1 week. So after you finish playing the games, by end of next week, reading week, basically you'll cast your votes, okay? And then we'll basically announce the results on the final exam day itself. I'll bring the badges and I'll give it to you. Okay, so you can actually wear the badges while you do the exam. Okay. Alright, so the other thing is this, okay, so because it's going to be a bit late, right, basically we won't be able to do the, vote counting everything, and so the EXP for this particular contest will be based on the effort, whatever, so we will use some EXP, because we need to tie up the loose ends, right, for the class. So, okay, so before we continue, let me tell you the statistics. Okay, so this year, okay, the bottom is the practical exam results for last year. So this year the results are better. Median is 29. Okay. So got 1 point, which is not unusual or unexpected. So I think on the whole, you guys are a bit stronger than last batch. Okay, but then the fact is that you also must take into consideration that last batch was 65. You're currently only 43 of you. So on the whole, it's not expected that with a smaller group of people. Essentially, on the whole, you're better. Right, so you're a little better than last year. And, okay, I think, okay, so all of you pretty much would have received all your PE results, right, by email, by your tutors. Okay, because what happened was, the reason why it wasn't handed out directly to you was because two things. First, I wanted the tutors to check basically the grading. Number two is also so that they understand how well you're doing, and then give you some comments. Because I have no time to give you detailed comments, but I've tried to give every single one of you a sense of where you stand in the class. Okay? So although the point is this, although this class is supposedly hard at 1010, the general sense is that we try to ensure do some kind of moderation across so that you are not prejudiced against in terms of your overall grade compared to 1010, because 1010 is a little easier. Your PE is a bit easier, okay, somewhat. Okay, so your PE is not that hard, but frankly, it's compared to their PE, I think it's a little more challenging, right? Have you seen their PE? Huh? Okay, so to be fair, okay, you're agree. Who think the PE is too easy? Not the good grades, that's not good. Who think it's too easy? The PE. It's too easy. No, but you must understand, see, 1, 2, 3, okay, let's be fair, okay. So the objective of this class is not to kind of you get very poor grades. No, that's not the point, right? The whole point of this class is to ensure you learn how to do programming, right? So the first 3 questions are designed, frankly, to test whether or not you figure out how to solve problems, right? So they're not hard, but they're not completely trivial, right? I mean, you do require, you look at it and it's done a while, okay, not very long. The last session is done for a long time, but the first 3 questions, you're supposed to be able to do it, most of you, okay? You can't do it because I'm a poor teacher, right? So obviously it's not so great, right? Right. So the fact that most of you can do it is a good sign. Okay. 4th question is meant, like I said, to waste the time, to basically soak up all the time you have left, right? Okay. I'm pleased to say that I get a few students who can actually solve the last question. But then, every year is like that. So there are a few students who actually can solve the last question. Okay. In some way, and then Caleb Chow got kind of bored, and then he also wrote a solution, which is this difference thing. Okay. to an extent, the last question is really for fun, right? But the interesting thing is that it shows you how you can apply numerical differentiation, right? I think you covered in class, right? We did cover in class the numerical differentiation. Okay? So the fact that you guys didn't apply, it means that you haven't quite internalized it. Okay? But really the whole the general idea here is to see whether you have figured out some of these things. So, okay, so yeah, the key question is this, hopefully you all have learned something, okay? And the one reason why I actually give you the solutions to all the exams, especially so that you can look at the solutions and pretty much figure out how you can do things. So one of the issues also is that although many of you can solve the questions, some of you don't solve it like using the most straightforward method. Okay, so the solutions give you a sense of what is kind of standard method, right? For like question 2, the solution is 6 lines long or something. Alright, question 1 is also quite short. Alright, so the point is some of you basically can solve it, but you all take a little bit longer time to solve it, right? So the whole point is to expose you to certain solutions and to think different. Okay. Now the way it works is this. Okay. So far, how many of you checked IBM gradebook? All correct. I guess all correct. I thought you were sending email, right? So the thing is that all your midterm exam solutions, midterm exam results are in. Your practical exam results are in. Midterm exam results have actually also been modified by the PE already. Okay. Now, obviously, GFA Academy will close hopefully by, I forget when is it? The last edition? Probably Sunday, right? I can't recall, but the thing is that it turns out the game was a great game, but this game has an ending, and it's going to end I think Sunday or Monday or something. Okay, so basically by probably middle of next week, right, we will basically pretty much end the game. In fact, Manchester has finished long time ago, right? Okay, so how many finished the game already? So one, two of you. Anybody else? Okay, well, good for you. A few of you have finished the game. So hopefully by I think Sunday, okay, all of you will finish the whole game, right? And then we basically tabulate the scores. Okay, very simple. Your level will translate into your CA grade, capped at 35. Okay. All right. So by next Friday, I hereby ask that all of you will go and check IBLE, okay, and make sure that the grades are correct. It's your responsibility to check. Okay, if it's wrong, then it's too bad. I mean, we try our best, okay, to ensure it's correct. Okay, but I really cannot be completely sure that things are right. Okay, so I ask that you all will check these things, and then pretty much by end of reading week, everything is confirmed already. Okay. Questions? Okay, there will be a 5% participation grade thing. The way it works for that one is that it's kind of a reflection of your relative activeness in the class, right? So out of 5, if you get 1, it doesn't mean you failed. Right? The 5 points really is for the tutors to feedback. Okay, essentially we discuss. Okay, essentially for every station, every tutorial. Okay, we will basically have a distribution, and probably some will get 5, some will get 1, whatever, to split up, so that there is a sense that the students. Okay, so suppose you are not doing so well in the practical exam, the final midterm exam, whatever, because you just freak out, right? But then you are a very consistent student, then maybe we'll just give you 5 or something like that. All right. So that this is just to kind of have some human element to balance out the kind of things that can go wrong in exams. Okay, because there are always people who actually know what they're doing, but then somehow exams just don't perform. Okay. Final exam. Last thing with final exam is that I think it's very standard, right? So I don't think it is my best final exam, but it's okay. I mean, there'll be one interesting question, whereby interesting. I mean, last year is really interesting. I think last year I was really inspired. Okay, so my final exam last year is really interesting. But in terms of standard, right? I think it's about the same. Okay, so you expect the same kind of feeling, I think, for the midterm exam in the final exam. Maybe answer will finish early. Okay. As usual, and then some people will not finish, okay? And in order to finish the entire exam, pretty much you need to have mastery of the material. Okay, normal okay. The whole exam, okay. The whole point is to test how much of mastery you have achieved in the stuff you're supposed to know, right? So, if you have, okay, A students should be able to finish the exam. Okay, may not get everything right, but finish the exam. The A plus student should be able to get like 85 to 90 something for the exam. This is how the exams are actually calibrated, okay? Questions? Alright, so you will expect the same thing. Sadly, some people will combust, okay? It is a tradition. Every cs11s final exam, some people will combust. And some years, design years especially bad. Design years, a lot of people combusted, okay? So some years are worse than others. Sometimes, okay, so some A plus students, okay, the good news A plus students that they combust, they will probably get an A still. Because some of them, the grades are so high that they have to pass with an A. Okay? So that's good news for them, right? But it is possible to combust at any level. Okay, I've seen A plus students combusting, I've seen A students combusting, pretty much. Okay, so most of you have some kind of a standing right now in terms of where you are in terms of your grade. Right? If you preserve the same level of performance, okay, so this is roughly an A grade for the final exam is about 70. Okay, if you can get 70 or 100 for final exam, it's pretty much the A grade. Obviously, your current standing was an A, then you have an A, then the overall average is an A around there. Okay, roughly. Those guys who want to do A plus, you need to score like 85 to 90 something for the final exam, and it's possible. Every year people do it. Okay. A minus, I don't really know. I mean, we will see where the line is drawn. Okay, but let me explain to you the following. Okay, the way it works is the following. It turns out next semester there's this thing called 2020. How many of you have talked to the seniors on 2020? What's the feedback? Nasty, right? It's actually nasty, lah. Okay, it's actually the feedback is nasty, lah. Okay, so this semester you get an MIT guy. Okay, next semester 2020 another MIT guy. Okay, welcome to you. Welcome to NUS. Okay, so the problem with MIT guys is that nasty classes are. Okay, but nasty in a good way, right? Now, so the moral story is not that we're not trying to be elitist here. Okay. So what I will try to do is do your service, right? And I'll explain to you how it works. So you all will do the final exam. Okay? I will do the grading, everything. And actually what happens here is this, right? So A minus is actually the cut-off bar for 2020. Okay? So so the question is what is A minus, right? Let me tell you what it is. A minus is I stare very hard at the students. I will call up the practical exam, look at how you write a code. I will look at exam scripts and think and consider, will you survive 2020? I'm serious, sounds funny, but it's not funny, because the truth is last semester there were like, okay, so if you get a B case, this is the deal. 1 A minus is the minimum bar to take 2020. Okay, B plus you can appeal. Okay, and I have like 3 or 4 students last semester, A B plus taking 2020 will appeal. I think only one of them did well, the rest of them basically combusted quite badly. Okay, so the real challenge here is this. The real challenge for me is not to be kind and give good grades. Right? That's not my job here. Right? Okay, my job is to help you get better. Okay, my job here is to basically assess as best as I can. Okay, what level of competency you've reached in your programming. Okay, maturity. Okay, now if you don't reach that, it doesn't mean you're bad, or it just means that probably you should take something that's not so accelerated so that you have more time to catch and do well. I say again, the important thing here is not how well you do in your first year. The important thing is how well you do in your 4 years. Okay, so the problem here is really we want to make sure that the students, okay, the first year students, you take time to adjust, okay, and then make sure that you actually learn at the right level, okay? Because if you go 202 and it's too fast, okay, and then you combust, you combust meaning you may not fail, you get a C or something, then you can't know the stuff not very well. Alright, it's very bad for you in the future. Are we over here? Okay? So any final concerns or questions? Okay, this is very relaxed because everything is covered already in the exam. Okay, so as I say, so basically the exam covers everything up to last week. Okay. Okay, so today there's not repetition because it's okay. This is the problem with Java, right? Java is completely new. Okay, and pretty much I can cover more. But what I'll do is that I cover something, and now the first part of today's class, I will pretty much revise some of the things we discussed last week, okay, and give them some more details. Okay, repetition I think is important. Okay, first of all, this is very, very important, equality. Because equality is a big problem when you actually get bugs. So again, the equal operator in Java is equivalent to EQ question mark. Okay, it basically tests for identity. Okay, whether two objects are the same object. Okay, or whether and for primitives obviously they're all the same. So equal will be equal to equal, just like in scheme. Okay, and then the thing is that there's also this equal method in objects that needs to be overridden. Okay, in order for the equal, which is equivalent to the equal question mark in scheme, to do the right thing. By default, it's equal. Okay. Again, this is kind of vague, but today, that's Restation today. Restation today, we'll go through some of these examples, in class to make sure we nail this in. Okay. And basically, the thing is that the two things equal to hash code. Okay, and the string. Okay, so this is what we'll cover today in Restation. Okay, how we do this physically using Eclipse. Okay, so this is a vector object. Okay, and pretty much if you do this, you get the wrong answer. Okay, fundamentally, the reason why you get the wrong answer, you don't get the answer you want, is because over here I have just defined this very simple class that only has cost that keeps two kind of variables, right? And when I print out the thing, I get some random stuff, and when I do equals, it's wrong. Okay, because by default the equals operator, right, will actually default to equal. But because V1 and V2 are actually different objects, so the last statement will return false. So the solution here is actually to do two things: override string, okay, so that I print out something that's humanly readable, and I override the equals method. Okay. Now in this case, this thing is important to remember. Start off, because this is kind of like the canonical law. Okay, Ryan, wake up. Okay, this means that most times when you need to override, right, you will write it in this kind of format. First one is instance of. Okay, instance of. This is the command here. This method, right? This kind of operator basically checks whether O is a type of vector. If the vector V is actually if O is actually a subclass of vector, will it be true or false? True. Means if O is not just a vector but is a subclass, okay, it will still return true. Okay. Now this thing here, let's just try to highlight again. This thing is what? This is a not. So this thing returns true, then this thing not becomes a false. Okay. So essentially, it's checking if this vector is not instant, if O is not instant of vector, you return false, which is true, which is obviously the case, right? Now, if this thing passes through, it means that O is obviously a vector. So what you do is then you cast the O to be a vector, and then you do the comparison. Okay, typically what happens here, the bottom part is that you do a laundry list. You do a laundry list of all the different internal states. Okay, check whether it's equal. Now, sometimes you use equals, sometimes you use equal, if the object. Okay, so. And hash code basically is something that you need to generate. Okay, the typical way of doing it is that you take the state of the object that you created, you multiply different parts by different prime numbers, and you add them together. Okay, the theory here in a kind of a cheap way is that you will essentially, what you want to do is this: you essentially want to do the following. Given any object, right, you want to basically generate a number that's unique for the object. Okay, such that if two objects are different, it generates a different object, a different number. Okay, and also that two things. You want to, for each object that's different, it generates a different number. Okay, integer. And for two objects that are equivalent, they must generate the same number. Okay. Now, if you screw up a little bit, and if two objects, okay, are different, and they generate the same number, how? Is that a problem? It's not really a problem, because okay, the way it works is this. Let me just explain it more carefully. So the hash code, okay, what happens is this. This hash code thing is used when, okay, this is what I repeat myself, because this is an important concept. So this hash code is used when you try to put this object into what's known as a hash table. Right. The way hash table works is that hash table is divided into buckets. Okay. And the way it works is that you take object, you hash it, you get a number. Okay. And you do a modular operation. Okay. A remainder operation to put the object into one right bucket. Okay. Now, so the idea is this: if two objects are equivalent, they must always go into the same bucket so you can find the stuff they put in. Right? Because it's possible that you use one object that you put in, and then you need to check another object that's equivalent when it's inside the set, and you must in there. Now, what happens if you have two objects that are different, but somehow go into the same bucket? Yeah, so actually it doesn't really matter. You just have more things to check. Okay. Now, in the worst case, the worst thing you can do that's kind of still correct is you put a constant there. Right? What happens? What does that mean? It means every single thing you put in the same bucket. No? Will it break anything? Not really. You still sort of work. But your hash table is completely useless. No? Because hash tables, hash sets become order what? Order n, right? Because that still happens is that you, instead of, the whole point of this hash table concept is that you basically take a whole set, you divide into a lot of small little sets. Okay? So you need to check, right? You can just hash and know where to look. And if it's there, it's there, not there, not there. The problem here is that if every single thing gets hashed into the same bucket, then good up to you. You go and check, you need to check through all elements all over again, so there's no help. Okay, that's the general idea, okay?
So when you propose the equal, you check for the hash code first, then you check.
I don't think so. Equal will just do direct access.
What's the point of it if you don't use it?
No, this is for operations relating to the hash set. That means this idea, when you, okay, I can explain the question. So you have an object, right? There's some kind of hash table. You want to put the thing in the hash table. You take the object, you call hash code. It generates a number. Okay, the table is some size. How you do it, don't care, but some number. Okay, and then you take this object, you hash the thing, you modulo the thing, and put it in the right bucket. Okay. Now, suppose you want to now have another object. Okay, and you basically want to check whether it's in the table. What happens? You do the same thing. You do the hash code. You do the modulo. You go to the bucket and check whether it's in there. Now, to compare two objects, it's very simple. You take the two objects. You just go and check. There's no need to do this hashing stuff, right? Makes sense, right? The problem with hash table is this, there's one big table, a lot of stuff, right? You have no idea where it is. One dumb way of doing it is to go through every single and check. This, you have an object, you can go through every single thing in the table and check whether they're equivalent. But what the hash function does is it lets you go to the bucket that you actually need to check what's in the bucket enough. Okay? Is that good enough? So essentially, the way to look at it is this equals method, right, is sufficient when you need to compare two operators, because you know two objects, it's obviously these two objects. The problem here is when you have one object and one whole big mass of stuff. Okay, again, or whatever classes in the future, you figure this out. But just to take note of this. So once you fix this thing, you'll be fine. Okay, we'll see this tomorrow. This afternoon, sorry. So this is how you actually import objects. Okay, so again, what you can do is that you can have this libraries, okay, and this import command allows you to import this whole object. This is similar to requires in Scheme. Okay, so once you import this, okay, what this does is it imports one object. This one imports the entire directory of objects. Okay, now once you import object, you can use it just like a type. Okay, and you can create objects. Okay. And the way it works is this, for all the files in com/banliang/ku, okay, you should pretty much include a definition called package to let them know that the class is in this package. Okay. Now the next thing I want to talk about, so the reason why I'm talking about this is because now I want to talk about access control. Okay. Now it turns out that remember, objects and methods. They actually have this thing in front, typically, a modifier, right? And this modifier has got a few different possible choices. First is public. Public means what? Means that anybody can access anywhere. Okay. Second is private. Private means that you can only access within the class. Okay. Protected. Okay. Protected means that you can only access within the class and by the subclasses. Now, this is something that's not obvious. People think that all you have is this tree now. There's just three different types. But actually, there's a fourth one, which is called default. That means it is possible to define an object and actually not state public, private, or protected. Okay. Now, an object that doesn't have these three modifiers has the last thing, which is called default access. This is only accessible within a package. Are we clear? Okay, what's a package? A package is a directory. So, for example, if the object is called this thing, it means This means that it's stored in com/value/cool/cool object. That means there are other objects inside this cool, right, under this cool directory. So this cool directory is actually the package. That means if you have default access, you can access this list of objects, classes, methods, whatever, within only this package. Alright, again, this may not be completely obvious now, but at some point in time, hopefully you understand this. Okay? Now, the question is, why do you want to prevent access? Encapsulation. So the main problem is this, right? Now, the main problem here is this. You basically, okay, if you are the only guy writing a program, it's fine, no? Because you pretty much know what you're doing. Now, the challenge arises when more than one person writes a program, right? So I write something, you want to use my code. So the whole point here is that you may not completely understand my code when you try to use it, okay? And the point here is that if I can prevent access, I can not just prevent, I can restrict access of you to my code, okay, in certain ways. Two things. First of all, I prevent you from doing damage to yourself, okay? And secondly, what happens is that it gives me the flexibility to actually replace code, to update code, modify code without bringing your code, okay? So that's why this is important. Now, how does Scheme do it? Scheme doesn't do it, frankly, okay? So obviously, if you do message passing, right, you have some means of doing so, okay? You have some means of doing so, but obviously in the practical extent, you read something, right? For some classes, you have to create some new methods. Okay. So now the question 3 is quite simple, but it's not so obvious also, because if you just do the 3 functions ask you to do 3 methods ask you to do, you get stuck on. Confirm you get stuck, right? You actually have to define some new basically methods to give some access, right? Correct. No choice. I don't know what I mean. You get stuck basically. So the whole point realize you need to create these things. Now the problem with Scheme, you message passing, you hide some things is that sometimes you're forced to give access for yourself. The problem is that once you open access to yourself, the whole world has access now. Alright. So the problem with Scheme is that it doesn't support this kind of more fine-grained access control. Whereas in Java, because of these things, you can actually design a program in some way whereby it's actually safer. That means you can give access certain things and not give access other things, and it's okay. Alright. Again, this is too deep for me to explain. You guys hopefully in the next few years will figure this out. Maybe next semester. Okay, now let's go back to our recap. So remember, this is our complex number world, right? Okay, this is what complex numbers are about. Okay, this is the way we do it. Now, so remember, back in the Scheme world, there's Ben who provides the rectangular representation, there's Alyssa who does the polar representation, right? Now, the point here is that, again, you want to create this thing called the complex arithmetic. Okay, you all remember how to do it, Now, so this is how it's done, Lecture 7, right? You basically do this kind of basic operations, right? You call it add, you multiply, whatever. And essentially, you want to implement this procedures. Okay, so remember this is Ben's code, okay, the rectangular code. So essentially, it does the right things, okay, in Scheme. Now, it turns out that what you can do is you can do the same thing in Java, right? So essentially, you define a class of complex, okay, and then essentially you double x and y, okay, and then you basically have all these things. Real part you return x, the imaginary part you return y. The angle is what? Angle is arctangent, y over x, okay, and then the magnitude is square root. Okay. Now, okay, and then how do you? Okay, this is what I do. Okay, I create a complex xy, and then I have this particular procedure called create complex from imaginary xy, return the new complex. Okay, what have I done here? I have made the complex constructor private y. This means that you cannot call a constructor from anywhere outside this particular object. Right? Which means what? But of course, it's not completely random, right? What I've done is that I've created what you call a static constructor method, okay, which allows you to call it. So essentially, the only way to create a complex number is to go through this procedure. Okay? Are we clear? Yes?
You can't override the complex part, the constructor is private.
Cannot. Right. So once you have a private constructor, you can no longer override you can no longer subclass it, I think.
Maybe you have a public constructor as well.
Yeah, unless you are public constructor or protected, whatever. But the whole point is that what I'm doing here is I'm showing you how I apply the modifier to prevent access to the constructor. Okay. Now the question is that why the heck do I do this, right? Okay. Never mind. You can't be first. We just observe this. Now, and the reason here is that I have another constructor which is called what? Create complex from magnetic angle. Okay. So essentially there are two ways for me to now create this object. One way is to call this particular method. One way is to call this method, right? Now, but why do I want to do this? Very good. So the reason here is, okay, now look at listeners code, right? This is listeners code. Okay, I won't go through the code because it's the same thing that you've seen before, right? Now this is the Java version. Okay, now you look at it. It's the same thing. I mean, you have now, I keep the magnetic angle. I basically have a real part is just to return this thing. Imaginary part return this thing. I can angle magnetic return these two things. Okay, and then essentially this is how I will do it, right? Okay, I'll have private again, and then static. I do this. I have this thing. Okay, so it's again in the listeners code I have two things. I have the create complex from real imaginary, and I have create complex from magnetic angle. Yeah, it's clear now, right? Now the reason is this. Look at this thing. This constructor looks like this, right? This constructor looks exactly the same. Although this x and y, this is magnetic angle, they look exactly the same, right? So the problem here is this, right? If I let you go and basically just do new complex something, right? You have no clue what's going on, right? Okay? Now, the question now is, you still have no clue what's going on, right? They still look the same. So how do I figure this out? Well, it turns out that I didn't say that I was sneaky about it, but the way that I separated the two pieces is the following, a very simple idea. One is called package rectangular. One is called what? Package polar. Okay. So the way that Java has done this is that you can create packages and automatically you kind of split the same. You do the same procedures on both sides, same name of the object, same methods, but they're somehow kept separate and they can kind of coexist. Okay, using the package. Okay, so this is a very interesting feature. Okay. Yes. Two different files. There are two different files stored in different directories. Okay.
And this is can many packages exist in local?
Can many? No. A package is a directory. So a package one package can contain many different objects, but one object cannot be in many packages. Okay. So notice the situations are the same. Implementations are somewhat the situations are two different implementations are identical. Okay. The difference here is actually the package declaration. Okay, and the other key difference is actually the internal representation. Okay, so next question is this: how will you implement complex arithmetic, right? Okay, so essentially there are two ways of doing Java coding. Okay, two ways. Okay, now the first way is what you call procedural, which is the C style or the C style. The other one is what you call the object-oriented way. Okay, now let's take a look. Now, obviously you know how to build complex arithmetic. Okay, now there's two ways. First way is this. I want to create this thing called complex arithmetic as a class. Okay, now first thing I want to do is complex add. Okay, this is known as the procedural way, which means what? I will define this add method. Okay, the add method will do what? We'll take two complex numbers, add them up, and return a new complex number. Right? What am I doing here? I'm just doing the normal thing, right? I take the real part of C1, real part of imaginary, and then I create this new number and return it. Okay? Simple? Nothing new, this is just the normal way that you write procedures. Subtract, same thing. Okay? Now, you can multiply also. Okay, multiply, same thing. You do what? You basically take the real parts, multiply together, you take the real imaginary parts, multiply together, and you minus out. When you wake up. Okay? So, divide, same old thing. Okay? This is known as the procedural implementation. Now, let me show you another one. Okay, so this is how you use it. Complex C1 is this thing. You create a new number, 1, 1. C2, another number, you add and subtract. Okay? And you get this number. Okay? Now, polar how? Okay? What happened? the reason why is this happening, right? This is happening because the internal representations are not the same. One is, so this is what happens. But essentially, if, okay, what is NaN? Not a number. Why is it happen? Because of zero and zero happening, okay, due to the fact that the internal representations are different, okay? Now, okay. No, you're just doing the same thing as you just follow all this. These are kind of common sense things that you do, right? But my point to you is that based on these operations that you do, okay, depending on whether you use polar or rectangular, you have this thing. Okay, now how do you decide between the two representations? This question. Yeah, essentially, what happens is this. You see, the code is the same, though. Okay, you can use either polar code or rectangular code for this thing. The only difference that chooses between the two implementations is the import statement. It means before this is the import, yes. How? Right. Yeah, correct. If you import both, right, you need to call them by a long name, okay, which is kind of a pain. Okay, we'll talk about this in class later, but typically you won't do this, okay. Now next. Okay, so this is known as the OOP implementation after you pick up. Okay, so this okay, now notice that earlier on what happens is that we have this. Okay, take a look. In this particular procedure implementation, you have add, you take two complex numbers, return a complex number, right? This is the normal C style way of doing it. Okay, now to do it OOP style, essentially what happens is this: you don't create this static method. This is now this is a static method, which means what? You can what? You can call this at the level of the class. That means you can do complex arrays dot add something happens. Okay. All right. Now this new one, okay. Hey, sorry. Yeah, this one. What is this method now? This is not a static method, right? Which means what? It is called within an object. Okay. So what's happening now is that you can add complex C to where? To what? It's to the current object. Okay. So essentially, this X is X from the current object. Cx is X of the new object C, and then you add together to create a new complex number. Okay. Now, okay. Okay. The thing is this. Now you need for this. Okay. The first case. This way. This procedural way. Does it matter whether it is a polar object or a rectangular object? No, is this for polar or for rectangular? Wrong. This is actually for both polar and rectangular, right? Because it doesn't matter. Okay. Right now this is rectangular, right? Obviously. But if you change this to polar, will it work now? It works perfectly fine, right? So the interesting thing is this. Now, don't keep this in mind. Now, this particular operations are general operations. It means you can change the representation of the complex number and it's fine, except for this problem, right? Except for this funny problem which I showed you, which is that it's not quite fine, okay? Because there are some assumptions in the operations which are correct operations. It means these operations that I'm implementing, they are the correct mathematical operations.
Because they're using floating point.
Yeah, except I have this floating point kind of stuff that's going on. I have this division thing that's going on which I need to take care of the zeros, right? So that's why it's a little bit broken, but conceptually it actually works. Okay, Ken, Ryan? Okay? Now, if you have but unlike scheme, you don't have okay? So scheme, by the way, is different precision. They'll take care of it for you. Now this one, okay, so for OP1, it turns out what? You need to implement, this is the one for rectangular. There is this code is actually in the rectangular package, okay? And similarly, you have the equivalent code for polar for the polar one. Because what happens is this, the idea is this, the idea here is that when you add complex to complex, it should be the same type, right? So you know that's why it's x plus cx, y plus cx, y plus cy, whatever, okay? Now, then the thing is that over here, you know that you add the complex c is also for polar type. Okay? So obviously, in this case, you use the code, equivalent code. Okay? So this is how you use this version. Okay? Now, what happens here is that you will do compare and contrast. This is the old version. Okay? This one, essentially you do what? You do complex C1 is this thing, complex C2 is this thing. And what happens here is that I add C1, C2, right? No, this whole thing is in complex arithmetic class. So this one you don't need this. Okay? But if you're outside you need. Now look at this form, Palas vocab. You're very tired, okay? Okay, just endure. I know you're all very tired last week, but you endure for focus on this. Okay, that's not an exam, it's true, okay? But don't be a favor, do yourself. I'm trying to earn my pay, seriously. Okay? The stuff that you see here are useful for the long term. Okay, so don't just listen to me because you got finance to take, right? Listen to me because it's important for you. Okay? So compare and contrast. This is the current way you use the procedural way of doing it. Okay? And this is how you do the complex way. Now the creation is no different, right? Because you just create. Okay? The difference here is that now instead of having add C1, C2, what I do, I use C1 add C2. Okay, understand? So the general difference between procedural implementation and OOP implementation is that in procedural implementation, typically what happens is that you take a method, okay? You put stuff inside, stuff comes out. So it's a black box kind of thing. Okay? OOP implementation, typically what happens is that you take objects, okay? You shove stuff into the object and stuff comes out. It's okay, sounds a bit gross, but the problem is that, think about it, it's actually quite interesting, yes. Okay. Okay. So this is important. Okay, so the question David asked is this: will C1 get modified? Okay. Now the point here is very simple, right? You essentially whether C1 get modified depends on actually what's happening here, add, right? You look at add, okay, the state didn't change. Here you add, nothing happens. So essentially, okay, so it's very important, and that's why you all must get this in your head right clear. Okay. The first part of the class in 11S we did this basic operations, right? And all objects are what? They are immutable, right? Which means they never change. In the second part of the class, we started doing this fun environment model thing, right? And mutability, right? Okay. Now the concepts of mutability assignment, they are all universal. It's not a scheme only, right? Okay. Now back to the PE. PE is the polynomial thing, right? There are actually two particular methods in polynomial, right? Two different methods, right? One method is method to add, right? One method is a method called differentiate, right? They are purposely designed to be confusing, right? What do you mean? Okay, because one method will return a new object without doing anything to the old one. One method will mutate the object, right? Okay? Okay, now, so the PE is not that hard, but it's not easy also. I mean, it's designed to basically, do this sort of thing to you, right? So you must be very clear in your head to do the PE properly. What the heck is going on, though? Okay, some things change, some things don't change. Actually, I was kind of kind, to be honest. I was kind of kind because I actually give you test cases. Okay, pretty much, one reason I think why many people did well is because I pretty much give you quite a lot of test cases that are quite, it covers reasonable ground. Whereas if I didn't give test cases, you may have gotten wrong because you're not clear about this kind of differences. Right? So the key thing here is to keep in mind, okay, this idea of mutability and immutability. Okay, so you ask this question, it's important to let me ask you a question. Now, so how about Java? How do you control mutability? Okay, essentially every object by default is mutable. Okay? Except that you are allowed to define this thing called a final keyword, this keyword called final, to prevent the thing from mutating. But it is also a little bit obscure. Let me explain to you why. Because Okay, this time you have to focus because I don't have slides, so I'm just speaking off the cuff. So the idea is this, right? You can actually have variables in objects. Okay, just pay attention, whereby you define final variable something. So what you do is you have to do this, right? And essentially this object has this variable which is final, which means immutable, right? It doesn't change. Well, not so simple, you see. If you define this object final something, object something, this reference cannot change. But the object that you put in the final, if it's mutable, it means it can still change. Okay, so it's very subtle, okay. So the problem here with this form of mutability is somewhat subtle, okay, and it's not so obvious. Now, what am I making sense to you? Maybe not a lot of sense, but one day when this thing bites you will make sense. Okay, just know the following, which is that final doesn't actually make things immutable. What it does is that given a variable, okay, this is very complex. It's a little bit subtle, so let's focus. So given a variable, I put final. Okay, this final some object something equals something. What I can do, the final does that it basically fixes the binding. It means this variable can no longer reassign. Okay, it's assigned to this object is assigned to him, and this variable forever bound to the object forever. The mutability of this thing depends not on this binding, but on the mutability of this object. Make sense, right? Because if I bind the object permanently to this thing, let's say it's mutable, I'm screwed anyway. But the point here is that as you define objects, you can possibly make objects immutable. How will you actually do that? Not real-time variable. The whole point is that you make an object immutable by controlling access to the object using your access control modifier. Okay, so now let's take a look at this thing. Okay, this object, complex. Okay, in fact, two objects. There is complex rectangular and complex flolar. Okay, are these objects mutable or immutable? Either one, you pick your choice. They are both immutable or both mutable. Which one is it? No, not usually. This implementation. No, it's not usually. This is one implementation. It's a very specific implementation. Not usually. There's no usually. It's this one. Is this implementation mutable or immutable? Who says it's immutable? Who says it's mutable? Okay, this object is typically immutable. Because why? Okay, but I'm not very safe here. To make it really safe, I will make magnitude angle private. Okay, but given the way this thing is assigned, typically you won't be using this thing inside polar, right? You're using this thing outside your code somewhere, right? Okay, this means that magnitude angle, they're actually untouchable from the magnetic angle is actually inaccessible. So you cannot actually change the internal state of this object typically from where you use it. Okay. Now that means what? That means you can only access the object through the public methods, which are magnitude, imaginary real part, angle magnitude, okay, and all these things, right? Okay, these methods have no way. Okay, this object has only two states, internal magnitude and angle, and the way to mutate the object is to change these two states. Okay, if you no longer have ability to actually change these two internal variables, the object is effectively immutable. Are we clear? So the final keyword so your answer is not quite completely right. The final keyword doesn't actually create immutable or mutable objects. The way that you create immutable objects is actually to go and implement it properly, okay, and to assign the correct the access modifiers to it, okay, to actually force mutability. Okay, so here, like I said, the intention of this example was to illustrate to you how to translate scheme code to Java code. I didn't do it completely well. I'm responding now to your question. Okay, very good question, excellent question. Alright. Okay, so these things are not considered exams, but you will need to know this at some point. So hopefully you understand. Okay, you're very tired. So let me show you something to try to keep you awake. Okay. Break time. This is the best part. The best part lecture, right? Oh, everybody here is here because of this thing, right? Very sad. Life is life for a lecturer. Okay.
So what we've got to do is make that change in those standards. That's where the shifts happen. It doesn't happen any other place. And I'll give you a very simple example. If you want to know the difference in people's lives, it all comes down to what are the things that are must for you versus shoulds. So let me tell you this. We said to have an extraordinary life, you got to have an extraordinary psychology, right? Extraordinary psychology means you got to live in an extraordinary state. To be in an extraordinary state, you got to condition your nervous system, your body, your physiology and focus to be at their best. Do you agree with this? Yes or no? Then to do that, though, you can do that. Why doesn't everybody? Not because you can't. We all have the ability. It's because of our standards. I remember a time early in my career, I was about 24, and I went to do a seminar in Boston. And in those days, a big seminar for me was like 125 people. It was a 3-day seminar, and we worked around the clock, and people made such extraordinary changes in their life. And at the end of it, I was feeling so fulfilled. I was thinking, my God, I'm 24, maybe 25 at the time. And I am so happy because I have found my mission in life. I'm doing what I love. It's making a difference in people's lives. This is extraordinary. So we finished about midnight on the Sunday night. And around midnight, I'm still wound up, so I don't feel like going to bed. So I decided, okay, let me take a walk here. And I decided to go through Copley Square. If you've been through Copley Square, it's a pretty neat place. Because in Copley Square, you can look up and you can see buildings that were here before we were known as the United States. And beside them, you see skyscrapers that are new. It's a pretty cool place. So I'm walking around midnight on Sunday night. There's nobody in Copley Square midnight on Sunday night. And I'm walking along, and I see this guy in the distance, and he's kind of stumbling back and forth between the gutter and the sidewalk. He's got a long trench coat on, his head's down like this. He's holding a brown bag, and I can start to smell him even before I get there, and I'm thinking, this guy's obviously drunk. And as I started to get closer, I thought, I bet he's going to beg me for some money.
Yeah.
And sure enough, whatever you focus on life tends to happen, doesn't it? So sure enough, he gets real close to me, and I thought all of a sudden he wasn't going to do it. And all of a sudden he popped his head up. It was really weird. He went, "Mister!" He had this really bizarre-looking sounding voice. He went, "Mister, could you loan me a quarter?" And I thought, do I want to reward this behavior? And then I thought, I don't want him to suffer. Do you have this dilemma sometimes? Like, I'm not here to judge. So years ago, I finally decided I always just give. Even if the person's pulling a scam, that's for them to deal with. If I have the ability, then I give. And so I thought, well, could I teach him something? So I asked him a question back. I said, is that all you want is a quarter? So he goes, yeah, just 1 quarter. 1 quarter changed my whole life. 1 quarter. I said, really? He said, yeah, 1 quarter. So I reached in my pocket, and I pulled out my money clip. And in those days, I was, very young, just starting to succeed. And my original mentor was a man named Jim Rohn. I don't know, how many have heard of Jim Rohn? Anyway? Yeah, he's a great guy. And Jim told me, he said, Tony, look, you've come from a poor background. You got a poor psychology. You got to change it. He said, you don't have any money, so pretend you do. He said, start training your brain. Condition it. He said, go save all your money, get $300 bills, and put them on the outside of your money clip, even though you only have $5 in between them. So every time you put it out, you'll see that. You'll feel inspired. You'll feel better. He said, you'll feel better, you'll do better. So I was like, okay. So I did. So I pulled my money clip, and sure enough, I got $300 bills in. I made sure he saw the bills. So I'm tearing through that, right? Looking in between there to see if I can find some change. But I made sure he saw it. Sure enough, he's looking at the $100 bills, checking it out. I find the quarter, I pull it out, take the money, put it in my pocket. I notice he's watching my hand going into the pocket. I took the quarter, and I looked at him, and I said, sir, life will pay any price you ask of it. And I gave him the quarter. And then something really interesting happened. He took the quarter. He looked at the quarter. He looked at me. He looked at my pocket. He looked back at the quarter, looked at me, looked at my pocket, looked at me again, looked at the quarter, looked at my pocket, looked back at me and said, you're weird. And then he shuffled on off like this, right? And I thought to myself, wow, what's the difference between him and me? I mean, I was 24, 25 at the time, doing what I love most, have my mission in life, and he's in his early 60s, drunk on the street begging for quarters. What's the difference? And I thought, well, maybe God's blessed me because I'm such a good person. I thought, and he's such a bad person, that's such bull. And I thought, wow, maybe the answer to that question is what I just told him. Life will pay whatever price you ask of it. But you know what's interesting? You got to ask intelligently. In the Bible it says, ask and you shall what? Yeah, pretty good formula. You ought to look into it. But you know what? It says, ask and you shall receive, but I'm sure it meant ask intelligently. I'm sure that's what God meant. I'm sure he didn't mean bitch and you will receive. Whine and you will receive. I don't think that was the instruction. Now, if you were going to ask intelligently, there might be 5 elements of that. Number one, you'd have to ask specifically, wouldn't you? You wouldn't ask in a general way. People do it all the time. They go, I want more money. Fine, here's $1. Get out of here. Very often, you're getting what you're asking for. You're just not aware of how general you're asking. Clarity is power. The more clear you are about exactly what it is you want, the more your brain knows how to get there. Your brain is a servo mechanism. It's like a bomb. Those bombs, those missiles, they have a servo mechanism. So if the target moves, it knows what the target is, it follows it. Your brain, when you condition it, knows exactly what to go for and it'll find a way to get there. Do you ever buy a certain outfit or a certain car and suddenly see that car outfit everywhere? How many of you have had that experience? Say, aye. How come that car outfit's everywhere? It always was everywhere, but now you notice it. And the reason is because there's a part of your brain called the reticular activating system, the RAS. That part of your brain determines what you notice and what you don't notice. Your brain spends most of its time trying to make sure you don't notice because you'll go crazy if you notice everything. But when you decide what's most important to you, your brain goes after it. Everyone I know who's successful builds what I call an RPM plan. An RPM is built on the metaphor that the way to get from where you are to where do you want to go to the fastest is you got to build power, like in a car, RPMs. And the R stands for they know the result they're after. They know what they want precisely. If you don't know exactly what you want or you let yourself get beyond that into something general, you're not going to achieve it. Clarity is power. You've got to know the specific result you're after. What do you want? If you can't answer that question right now in your personal life, in your body, in your relationships, in your finances, in your spirituality, then you're not going to be as fulfilled as you want to be. Today we're going to have the answer to one of those questions at least. The second part of it, you got to know why you're doing it. Because you know what? You may get a big goal as soon as I want to make $1 billion. I want to bring peace to the earth. Why? Because as soon as you come up with a goal, all the obstacles show up. Unless you've got enough emotional drive to break through that, you're never going to discover what it really takes. So you got to get yourself past that. And the way to get past that is have enough reasons. Reasons come first, answers come second. This man did not know what he wanted. He did not have enough reasons. To ask intelligently, you got to ask specifically. To ask intelligently, you got to know why you want it, have enough drive to make it happen, enough juice to make it happen. If you don't have enough reasons, you will not make it happen. And the M is, what is your massive action plan? What is going to get you to actually follow through? Because the first plan's not going to work and the second plan's going to work, so you better have enough plans. If the first two don't work, you still got something else. Otherwise, you're going to be having excuses why it didn't work. So asking intelligently requires that. So if we're going to be extraordinary in our results, we've got to be in an extraordinary state. We've got to know what we want, and we've got to go use it.
Okay, wake up. It's not my fault, right, Betsy? Is it really not my fault? You're just tired, right? All right, so... Okay, what the heck was that about? Okay, now so this guy that you just saw, and for this guy, and some of you of course have slept through completely. Later on you will see yourself on Facebook, how cool is that? This is the first time, I actually take sleeping students in my lecture. I take pictures of photos of sleeping students in my lecture. It's kind of cool actually, although it does not reflect very well on me, but then life is complicated. Alright, so anyway, okay, how many of you want good grades for final exams and do well at NUS? Is that intelligent asking? Is it specific asking? Let me tell you the problem. Okay, so this let's just take a break from the talking about complex numbers. I think complex numbers is not very exciting. I talk about girls, sex, and money. That's probably more important. Right. So anyway, this guy, okay, this is the last lecture. So there's not much time much chance of me seeing you. It turns out that I will also be taking a break from teaching for a year after this. So it is possible that I only see you guys for one semester your entire life at NUS. It's quite plausible. Okay, many students take 7 classes with me. But the view that I'm not doing CS2020, I'm doing this nasty thing called cs1101s23, which is this iPad programming thing. and I won't be teaching the year after, so it's possible that I won't see you all ever again in class. Okay, I'll see you in NUS probably. I'm probably not dying yet, and neither are you. So I'll see you around, but I feel that I probably won't be seeing you in class after Friday. Friday will be last lecture. Okay, let's talk quickly about this thing, alright? So this guy is actually Anthony Robbins, okay? And he is obviously, who knows about this guy? You don't know him, okay? But okay, so this guy is some rich dude. He's a very famous, probably world-class, best in his class, kind of motivational speaker, right? I think Bill Clinton called him when he had trouble. Okay, right. Bill called him. Bill, how are you doing? Not so good. So apparently, Bill, I think, had trouble, with what, right? Okay, he was called. So this guy is a man who solves problems, and here he is giving one of his talks. And okay, how do you believe in this stuff? Or do you think it's just motivational bullshit? No. Do you believe this stuff, or do you think it's just motivational bullshit? Yeah. So this is the funny thing, right? Okay, so to some extent, okay, what's the local version now? What's his name? Adam Khoo. Okay. Okay. So no. So this guy do this stuff, right? Okay. All right. And that's the name of this thing. This thing is called NLP. Neuro Linguistic Programming. Okay. So does it work or does it not work? Okay, so the model answer in life is called, it depends, right? Okay, so this okay, so okay, as a lecturer, a teacher, right, I have studied this because fundamentally, okay, the job here that I have is a difficult one, right? It is not one whereby I'm trying to transmit information, because that's the easy part. Okay? In fact, you don't need me. All you need to do is recording, and then you just watch and you can get information. You can read yourself on Google. It's easy. So the task of teaching is not just about transmission of information, right? The main thing that needs to be done is really to change your mind. Okay? That's programming. Let's say my job, okay, in a nutshell, is to reprogram your head. Okay? Obviously, it helps to have a good programmer. Okay? But programming scheme code and doing the Jedi mind tricks is a little different. Okay? So the fact that I've studied these things for a bit. Okay? The truth is that there is some amount of truth and effect in this thing called neuro-linguistic programming. And to some extent, some people swear by it, right? Like Adam Khoo, they send the kids to this, don't know what I'm gifted, so are you, right? Camp, whatever. Okay? Are you going before this? Anybody here went Adam Khoo's camp? Scam money only. Maybe your brain's not flexible, cannot learn. How you know? Okay, so anyway, it's scam money only. But the truth is, for some people it works, and for some people it doesn't work. Let me tell you my view on this. First of all, these type of things actually can work. But what's the problem with education? The problem with education is that it's a continuous process. That means, in order for these things to work, I must be studying, okay, not just me, somebody, I must be studying brainwashing you day after day. For long enough, so the brain will stick. I basically think that all this these camps, they go for, send the kids there ship them for 1 week, 2 weeks. It's really giving yourself a break from the kids. Okay, that's the most effective thing. Alright. Now the kids may come back inspired for a while. The problem here is that it wears out. So the problem with education is actually the problem of long-term, basically mental reprogramming. Okay, so this is the key thing. Now, what it's saying here is important. So let me just explain to you. So what it's saying here, okay, this thing, I don't expect you all to be, basically transformed after watching this video. But I think that the key thing to highlight in this video is the following: is that a lot of people basically have this kind of illusions to say that, okay, I want to be rich, or in your case, I want to do well in exams, right? Okay. How well as well? Better than the C, fine, give a B, okay. All give B's, no good, no problem, okay. We all can, okay, will you be happy if I just give you all B's? And it doesn't matter if you get all B's. Okay, this is the whole point. The point here is that it's not about doing well in exams, I say again. Right, the point is that it turns out that 101S, okay, is really a foundation to the rest of your studies at one SOC, because fundamentally, in many classes in the future, you will see programming again. Okay? So, the thing that I want to encourage you, okay, in this class, okay, many of you, okay, are doing quite well, okay? A few of you haven't achieved complete mastery of scheme, and you know it, right? I mean, basically you sort of know, okay, the A students pretty much need to have mastery. It means I give a problem of a reasonable, okay, question 4 a bit much, okay? But 1 to 3, pretty much they're all reasonable. You should be all able to solve it with pretty much comfortably, okay? Some students haven't quite achieved the level of mastery, okay? And the point here is that I want to encourage you all to work towards it. Okay, so it's a mastery that's important. Your final exam is not so much a test of how smart you are, but a test of how much you master the material. Okay? And I think the key point is this, I think I will encourage you all to work towards pretty much mastering scheme well enough to answer. See, the point is this, after the exams, sadly or maybe you're happy, you have solutions, right? And my style is very cool one, right? Because you finish the exams at 11 o'clock a.m., okay, I will take about 15 minutes to pack out the scripts, walk to my office. 11:15 a.m., the exams appear at IBLE. I will send your email. Ooh, how cool is that? Right, and you can actually see the solutions. And the challenge obviously is that most times you see solutions, they're obvious, right? Okay, so your job between now and the final exams really is to go and figure out the material well enough, okay, so that it becomes obvious to you, not when you see the solutions, but during the exam itself. It really helps. Frankly, trust me, it really helps, right? Okay. Okay, so back to the class. Okay, so this is what we're just doing. All right, where are we? Okay. Okay. So, well, sorry, okay. So we just talked about two things, right? We just talked about the implementation, okay, of complex arithmetic in two ways. One is the procedural way, and one is actually the object-oriented way. All right, I encourage you to actually go back home and look through the code again and just make sure you understand the difference in style. Okay. Now, which style is better? Depends. Okay. So again. Okay. So if there's anything that you kind of learn from this class is that these are two very useful words to use, right? Basically, if I ask you a question, okay. So the point is this: I will not encourage you to try to smoke people and to say stuff you don't know. But it depends typically the right answer, regardless of it's very useful, okay. It depends normally, right? Okay. In this case, the answer is depends, right? Now, what are the advantages of the old implementation? It's actually cleaner, right? To some extent. I mean, you look at it, it's simpler. Okay? And essentially, the general thing is this, right? Now, the two, okay, think back. The procedure of implementation essentially is representation agnostic, right? Okay? Basically, apply the formulas to both representations. I actually have some kind of a method to convert out the thing and give you an answer. Okay? Then the old implementation, essentially you are sitting inside object, right? So the key difference here is that in one case you actually have agnostic, in that case you actually have access to internal state. The cool thing with internal state is that typically, right, once you can see it, right, you can do it more efficiently. Okay? So OP implementations, because you're seeing inside, you can actually be more efficient. It's actually more natural also, sometimes. Okay? The difference here is, however, is that more work. Okay, because if you look at the code again, what happens is the following, right? In one case, I just wrote one piece of code, okay? I can use either polar or rectangular, okay? And all I do is just swap the import statement, right? I import polar, I get polar, and I swap the rectangular, I get rectangular, okay? The other case, actually what happened was that I had to actually, write methods, a set of methods for polar, a set of methods for rectangular, okay? So this is what I did. Now, another thing that I didn't do, obviously, this example is this, right? In this example, what really happened was the following. What really happened was that I actually kind of didn't manage one thing, which is I didn't actually deal with the coexistence of two different representations. Okay, the general idea of the code earlier you saw was that I pick either polar or rectangular and I use 1. Okay, in both cases. Okay. Now, so the other nasty problem now is the following, which we didn't cover today, which is not that important, but you can think about in your spare time. Maybe I may have put down as a question of the day, but this is the idea. The question here, and then you go and play with it now. Okay, use the code, play with it. Okay. Question is this: suppose you now want to use both the polar complex number and the rectangular complex number in the same code. How will you do that? Now, notice that in scheme we actually did that, right? The problem set, remember? Okay. Okay. We actually dealt with that. So we haven't actually dealt with this thing yet. Okay. How will you do that? Okay. It's not so obvious, right?
If you don't write your own method, then it's not fine.
Yeah, but think about this, okay? And okay, the reason why we're going through this code also is the following, is that essentially your final exam case. Also, what I said that your final exam will only include things up to last Friday. Okay, and actually Andrew, you can put down the cover. I know you're sleeping. It's okay. That's to hide. So at least I know when you wake up. Now when you wake up, I also don't know. I'm still sleeping, right? It's okay. He has this the screen, and then he's behind the screen. I'm like, okay actually I know you're sleeping. So the point now is at least you put down the screen. At least I know when you wake up. Okay, it's okay. Now. So the thing is this: what you need to do for final exam. Remember this is important. Final exam, wake up for what? Is that the key thing in final exam is really you're not tested on all this object-oriented stuff. You are not tested on all the public modifiers, private modifiers. You're not tested on that. You are essentially tested on how to convert scheme to Java. Okay, very basic only, very basic. Okay, and that's why all the examples I've done in the last 3 weeks, what I've done, I've shown you the scheme code, I've shown you the Java code. Okay, 2 reasons. The first reason is that this is the level of proficiency I require of you this semester. Next semester, obviously more, right? Cannot be the same level, you're in trouble. Okay? Now, but number one. Number two is that I also want to draw connections, right? Because the problem of learning, okay, another thing about learning is that learning is about what? It's about connecting stuff you already know to new stuff. Okay? So one of the reasons why I'm doing it this way is to basically, hopefully you've learned the stuff in the past in Scheme. Now I'm trying to help you bridge the gap between Scheme and Java by showing you this is like this and this new stuff. Okay? Alright, so those of you who've been sleeping, it's okay. Okay, I know you're tired. Okay, not my fault, right? You're just tired, right? Okay, now the point now is that you go through this code, okay, and I encourage you to do 2 things. Okay, first thing is to read through the code, right? And to not just read, no. Okay, what you should do is read through the code one time, make sure you kind of know what's going on. And then you take the Scheme code, okay, refer to it, open Eclipse, and write the equivalent Java code. Okay, now this basically gives you the ability to translate. Okay, and the good news is this. The good news is that it's really quite easy. Because it's all syntax about familiarity. Okay, now second thing you can do, obviously, is to take other pieces of Scheme code that I didn't actually discuss in class and translate. I think Manchester wants to do translate what the space walls and everything, right? Okay, so he's done already. This guy actually can study for other classes. He has, he's completely done his class, right? Because he's even finished preparing my exam already. Okay, practically. Okay. Now, so the next thing I want to talk about, okay, so this pretty much ends. This ends the stuff that's kind of relevant. So even all these things, even though they are not actually covered in exams, they are kind of relevant. Now, I'll talk about something that's kind of interesting about Java that's different from Scheme. Okay, Java has got this thing called exception handling. Okay, I think I discussed this last lecture. Okay, and the idea is that, okay, you have code working and you have if-else statements that do some things, okay, and handle conditions. But sometimes unexpected things can happen, okay, and these things are called exceptions. Okay, sometimes they're bad, mostly they're bad, but sometimes they are actually accepted. Okay, now, so typically these events oftentimes cause for it to crash. Okay, and for Docker Scheme use, this guy's head popping out, right? Alright, so it turns out that this exception mechanism is something that most modern languages handle. Okay, even Apple does it. Although the funny thing about Apple, I learned is that Objective-C doesn't, although it supports exceptions, it's highly discouraged because it's actually poorly implemented, so it's very slow. but most modern programming languages has this. Okay, now the Java exceptions, basically when this exception happens and bad things happen, they will generate this thing called an error object that contains information about exception. Now, in the good old days in C, how did they do this? Yeah, they return this thing called -1, right? Which is kind of simple, but what's the problem with that? There's no idea what happened, right? I mean, the thing is return -1, right? So what the heck? So the whole point of this exception handling mechanism is that it gives you a chance, essentially, to capture the condition to return more state, okay, for processing. So the typical way of doing it is the following. Is this thing called try catch. Essentially, the try statement, okay. Essentially, this statement it encapsulates some statements, okay, some code, all right. And what happens? And after the try statement. With this parenthesis, there's this catch thing, okay? And there's some stuff here, and then finally there's some stuff here. So typically how this works is the following. This code here you run is then protected, right? When things blow up, okay, an exception is thrown, it will come out here and be caught. Okay? And this code tells you what to do, okay, if exceptions are caught. Okay? Finally, this tiny part, actually I never use it, okay? But it is there, which means that this is code that's always run regardless of not exception happens. Okay? So this is optional.
Does that mean you put it outside so it still run?
Outside where? Here?
Yeah. If it's an error, then you will.
If it's error, you may actually jump out. So you may have to maybe throw it there. Alright, so the point now is that's this thing. So the idea is this, generally speaking, exceptions are thrown. Okay. Now 2 things. Exceptions can be thrown by the system because things blow up. It turns out that you can also pretty much throw exceptions yourself in code. And how cool the way to do it is to use throw. Okay. And essentially it turns out the value can be, you can throw, the interesting thing is this, you can throw anything you want. Okay, but typically you don't do that. Typically you only throw exceptions, okay, which means that they should be of the type error, okay. And essentially there are 2 kinds of exception objects, 2 general classes, okay. One kind, okay, now I'm going to Java land, which is important, which is things that I think important for you to know, okay, which is not completely obvious. Turns out there are 2 kinds of, the 2 general kinds of exceptions. Okay, one are what you call errors, okay, and one are called runtime errors. They are different. Okay, now what's the difference? Okay, all right. So let's look at this one first. Okay, the first one is this thing called okay. So exception is actually the typical exception, and I implement this thing called my exception. Okay, this is how you implement exceptions. Essentially, what you do is that you just subclass exception, and you can put extra stuff inside. So what this thing does is that you can take the normal exception, subclass it, put more state inside. Okay, so that when you throw it, you can send more state up to the handler. Okay. Now this is an example to explain to you how exceptions work. Okay. So the code that I'm running is top right. Okay. So I do run. Okay. I do run some number. Okay. Now, if the number is more than 0, what I do? I will throw my exception. This exception is actually what I define here. Okay. Now, if the number is 0, I throw new runtime exception 0. Okay. And then otherwise, I throw new exception this thing, integer to string, whatever. Okay. So essentially, if it's positive, I throw my exception. If it's 0, I throw another exception. If it's less than 0, I throw this other exception. Okay, so what happens? Okay, now basically in run 2, I just throw runtime exception out. Okay, so there's run 1 and run 2. Okay, now so throws is what I said. Okay, so okay, throw here basically throws exception, right? It turns out that methods that throw exceptions needs to be declared with a throws thing, throws keyword, okay, and you need to tell what exception it throws. Okay. Now let's just try this. Okay. Now, look at this code. This is obviously not real code. This is kind of crazy code that you write, but just for illustration. So what I do is that, first of all, I enclose, okay, this is the code I want to run. I enclose it in a try statement, okay? And I put 1 here. What happens? Okay, what happens is that, because it's run 1, this thing is here, you go to throw my exception. So here, when you run this thing, you will throw exception, and it throws my exception. Okay? And then it goes there and prints my exception throws, you give you the number. Okay? Now, what happens when I do the rest? Nothing happens. Okay, because what happens at run 1, essentially, you will throw my exception, it will be captured here. Okay, the idea here is this. The idea here is that you can actually have several different exception catches, exception statements, okay? Right? And then, essentially, they catch different exceptions. Okay? Now, question. What do you think will happen if I take this particular statement, move it up in front? Yeah, so the key thing to understand is this. The key thing to understand is that when the exceptions are thrown, right, it will be floated up, okay? And you go through the different try statements, okay? And so if you take the most general one and put in front, pretty much the first one will catch everything, okay? So the reason why I order it this way is because they are in order of pretty much severity, right? I mean generality. So the first one is more specific, okay? You will fail if it's not my exception, and then you come down, okay? So if I put 0, you will do what? You end up here, runtime error. If I put -2, you end up in the last one. Okay? Now let's say I do another thing called run trees, okay? And in run tree, what I do is that I can do a run, okay? And then I can catch runtime exception, throw E. I can do this and handle. What's happening here? What's happening here is this, what I'm doing here is that if I do run, okay, and it throws a runtime exception, okay, I will throw E again. I will re-throw it up this level. If it doesn't, what happens? I will actually catch the exception and essentially kill it. I'll actually eat the exception, right? So what's happening here is that I am, okay, if it's a runtime exception, I'm re-throwing it, okay, but if it's not, I will actually eat it. Okay, now this is a subtle thing. Over here, run, I have thrown exception. Over here, I don't have. What happened? But I'm throwing something like. Why? Okay. Again, this is Java stuff. Okay, so let me just quickly highlight this. Okay. It turns out, okay, that the key difference between the two exceptions, the normal exceptions and the runtime exceptions, is that in one case, you actually need to define the throw. Okay. For runtime exceptions, you don't actually have to define the throw. That means, now this thing, if you don't have throws, what happens? Compiler will complain, okay, because what's happening here is the compiler realizes that you are actually throwing this exception inside the code. You need to declare this. Now, if you are throwing, here what's happening here is that you can possibly throw a runtime exception. Okay, the compiler doesn't expect you to declare runtime exceptions. Okay, the general idea is this: exceptions are actually not as exceptional. Exceptions are not quite as exceptional as runtime exceptions. Okay, runtime exceptions are stuff that is expected not to happen when. So when they blow up, it's really blow up. Okay? Exceptions are actually stuff that you oftentimes will throw because of valid reasons. And for that, you need to handle properly. Because runtime, okay, the problem is this, what's the difference between declaring exceptions? Okay. What's the difference between declaring the throws and not declaring the throws? If you declare a method to do a throws, it means that the code calling it must always have a try catch statement. Must always have it. Okay, so the problem here is that if you are too kiasi, basically you have this throws everywhere. The people using your code will be very annoyed because they are forced to just try catch statements everywhere. Okay, so the general idea here is that in cases whereby the exceptions are the norm, you will declare throws and use the normal exception. If the kind of exceptions are not the norm, right, then you typically won't use an exception. Use runtime exception. Otherwise, you annoy the heck out of the guy using your code. Okay, this is very subtle details. Okay, again, you may not. Okay, so I mentioned this. Use in C, good old days, use C-1. Okay, now basically these are the general ideas. Okay, it's more natural. Okay, Java is strongly typed, so you can catch these things. You can extend them to stand up more information. Okay, and you can also have nested exception for flexibility in actually controlling the flow. Okay. All right. So this is really my kind of last. I'm almost done already. So this is pretty much my last advice to you, which is that you don't have to know a lot of Java for this class. Okay. But you need to know a lot of Java and some Java soon enough. Okay. And there's no real shortcut to learning programming. Okay. So between now and finals, okay. First of all, go and finish up your scheme. Finish the game. Right? You have the academy. Okay. Level up. Okay, then you go and go through your passing exams. Okay, last thing I would like you to do is to go and use Eclipse to write code. Okay, this afternoon we'll talk about you'll show a demo in recitation. Okay, and pretty much let's quickly recap. This is exactly the roadmap. Why? Okay, I showed you this pretty much first lecture, right? Obviously it's all a blur, right? Okay. Hopefully after today, well, if it's not, then you are in trouble lah. That's what I can tell you. Hopefully after today, this thing all looks like completely clear. Like, oh, I know this too. You know. Okay, and pretty much we are now in this little corner here. Okay, and you all have basically mastered all these kind of cool things, right? Okay, so access handling is quite advanced. I've gone through some details. Okay, hopefully you will learn more yourself. The other stuff, there's concurrency threading, which is very nasty. Network programming, GUI. Okay, all these things. Hopefully you will learn at some point. Okay, in your more advanced classes, or you prepare yourself. Okay, this is the last thing I want to show you. Okay, so final exam will happen on 25th November, Monday in the morning, 9 a.m. Okay, to 11 a.m. The funny thing is this: I can't figure out where it is though. I checked the exam schedule, I didn't tell me which room, okay? But normally it's SR1, okay? That's SR1? Huh? Was it out? Okay, I tried to find it for a long time, I couldn't find it, okay? So hopefully before the exam happens, you'll find it, then I'll find it too, I'll see you there, okay? But then, the point is that, okay, normally it's SR1, most years SR1, okay? I suspect SR1, but don't believe me, go and check, okay, and I will try to figure this out soon. Okay, it's 9 a.m. on this day. Open sheet as per normal. You also bring 2 sheets, and the idea here is bring 1 sheet for midterms, 1 sheet for after midterms. Okay, you all know how the exams are, okay. It really doesn't help that much. It's more like Charlie Brown, the security blanket. You're gonna feel more comforted. Okay, but I think it wouldn't help that much. But what the sheets do is that it forces you to revise, summarize, okay, and figure out what's important. Okay, you will have an appendix as well for stuff that you might need, might not need, whatever. 4 questions, 2 hours. Okay, 100 marks. As per normal, not every question is the same difficulty. Not all the easy questions are in front. So do the easy questions first. Okay, if you try to do linearly, I think you'll be in trouble because very likely you get stuck somewhere and you get stuck. So you want to basically go through the whole exam, do the easy ones first. This is the end. Any final questions? No. Last year 29. 28, right? Hey, don't. Oh, the date is wrong, but the date is correct. Sorry. Friday. Okay, so it's Friday. It's a Friday 25th. I got the day wrong. Okay. So okay, don't come the wrong day, Okay, so it's Friday, 25th November. Okay? Question? Team shirt. Yeah, is that team shirt this year? Well, then maybe you'll find it organized. Okay. So most years, okay, not most years, out of this is the 6th year teaching scheme, right? Okay, just quickly, okay, at some time, 6th year teaching scheme, I think 3 out of 6 years they got their act together and printed a shirt. Right. The general market rate is that between now and next week, right, some guy will go figure it out the design. Now normally they print it and give out on the final exam day, and they wear it in the final exam for some strange reason. No, okay, the theory was this. One year was cute, one year theory was cute. One year theory was that it gives you extra real estate to have cheat sheets, so they have formulas, so you can sit the guy in front and cheat some. Okay, no. Honestly, if the teacher design is so damn good that he prints out the final exam answer on the shirt before that I give it to him, it's fair enough. Right, I mean, frankly, okay, but, if you feel lucky, okay, you can try that, okay, basically, try to predict the answers, then print it, then all wear it, then you can see the guy in front write down the answer. Fine with me, man. Okay? Any questions? So, so you can get around, okay, having a third cheat sheet, by printing a t-shirt and wearing it on the day. But then the guy who's sitting, okay, but the thing is, what you don't know is where you're sitting. So if you're sitting right behind, then sorry you lose the sleeve. Okay, I leave to you, frankly. So the point is that it's optional, okay? That's all I have for you, okay? And Friday is a very short lecture, but hopefully be interesting. And do encourage your friends to come on Friday. Okay, it will it will be my very last lecture for SCHEME. It's very cool. I think there will be more students than you coming back because it will be the last lecture for me. How cool. Okay, so with that, see you on Friday. Bye-bye.